The initial idea is to measure the impedance of my analog sensor with voltage division, putting a known resistor in series with my fabric, and by measuring the voltage at node A, we can measure the current and hence measure the resistance of the fabric. The initial plan failed due to the fact that the sensor was not working properly and the change of the node voltage in regard of expansion of fabric was not detectable neither by oscilloscope nor by our program. The voltage change was too small. Then I checked the ADC program with known resistors in series and in parallel. As I decrease or increase the impedance value, you can see the change is being detected by my program. The new approach is to use a linear potentiometer to show the change of impedance. The linear potentiometer is connected to a fixed point via a spring in order to bring the sensor back to its initial position after the knob of it has been moved by the breathing pattern of the subject. Linear potentiometer is just like a variable resistor which does voltage division and gives back the voltage of node A. You can see the sensor is working appropriately with my program. The output values are not exactly the voltage value that we know of. The max value of 4950 is assigned to the maximum voltage of 3.3 volt that we are applying, and the minimum value is 0, assigned to minimum value of 0 voltage, so we can easily convert any value that we got to voltage. The buzzer works when we enter the loop and send a signal to it. The sound of buzzer will change when we change the delay time. The on-on toggle switch is to turn on different paths. It will turn on and off my whole device.